When you think about construction, what really comes to mind first?
Hmm.
For a lot of us, I guess it's concrete, steel, maybe, those traditional methods we've seen forever. It can feel a bit, well, static.
Right. Predictable.
Yeah, exactly.
Right.
But what if I told you that the whole construction sector is actually at this really critical turning point right now?
Mm-hmm.
We seem to be on the verge of something quite extraordinary,
Mm.
a full-blown material renaissance in building.
And that turning point, it's not just some passing trend. It's really being pushed by, well, the undeniable urgency of the climate crisis, for one,
Right.
and also the fact that resources are getting scarcer. So this deep dive, it's all about exploring how construction is fundamentally redefining itself.
Redefining. How so?
Transforming, really, from this typically resource-heavy industry into something that could actually be climate positive, a circular economy.
Wow.
And interestingly, Europe is really acting as a kind of laboratory for this material-based sustainability culture.
Yeah.
They're leading the charge on so many different fronts.
Okay, this is where it starts to get really interesting for me. Because we're not just talking about, small tweaks or making old ways slightly greener.
No, not at all.
This sounds like a profound, almost top-to-bottom revolution. Rethinking how we build, using renewable circular materials. That's a huge shift.
Exactly. That's the core idea. Moving beyond seeing buildings as just, well, static objects.
Right.
And transforming them into what you could call living systems. And what's truly fascinating here is how material science, aesthetics, and ecology are all merging, synergistically.
So they're working together.
Yes. To achieve this, it's not just about how a building functions anymore. It's about weaving natural processes and beauty directly into its very fabric, its DNA, so to speak.
So, okay, let's bring this back to the listener. Why should you really care about all this? Because, this isn't just some abstract architectural theory, is it?
Not at all. This is a fundamental change. It directly impacts our environment, the cities we live in, even how we, interact with the buildings around us every day.
Right. Imagine a future where the buildings surrounding you are actively helping the planet instead of just, sitting there using up resources.
Okay, yeah, let's unpack that. Let's talk about some of these exciting new materials. Where should we start? Maybe with something people might know, but maybe don't fully appreciate.
Yes. Let's start with an established hero, but one that's often underestimated in modern construction.
Yeah, that is.
Wood. Without a doubt, wood. Multi-story timber construction, that's one of the biggest innovations happening right now.
Timber. Like skyscrapers made of wood.
Well, maybe not skyscrapers yet, but certainly multi-story buildings. Research from Linnaeus University, for instance, has shown that 8-story timber buildings, like the ones they've already built in Växjö, Sweden.
8 stories. Wow.
Yes, they're not just technically possible, they're demonstrably climate positive.
Climate positive.
That's genuinely a game changer. How does wood actually do that?
It's really fascinating. Basically, by swapping out fossil fuels for wood residues during production and construction, where these buildings achieve a negative CO2 balance over their whole life cycle.
So they take out more CO2 than they put in.
Effectively, yes. And that effect gets amplified because the wood itself naturally stores carbon long term. It just locks it away inside the structure.
Amazing.
And beyond the crucial environmental benefits, wood offers incredible aesthetic possibilities too. You can create these novel spaces with visible load-bearing structures, really showcases the material's natural beauty.
You can picture that. It sounds quite different.
And performance-wise, wood hybrid systems often outperform conventional materials. Think thermal and acoustic properties. This leads directly to what we call passive house concepts.
Okay, passive house. That sounds incredibly efficient. Can you just quickly explain what a passive house concept means for someone listening who might not know that term?
Absolutely, yeah. Think of a passive house as just a super efficient building. It's designed from the ground up to use minimal energy for heating and cooling through things like excellent insulation, really airtight construction, and often using the natural properties of materials like wood to maintain comfortable temperatures with very little active energy input.
Got it.
And that's how those buildings achieve, 40–50% lower primary energy consumption compared to standard ones.
So, okay, wood is this proven champion. It shows how materials can actively help the climate. But what if we push that idea even further? You mentioned living systems. What if buildings weren't just made from living things, but were, in a sense, living themselves? Tell us about these living building materials. Sounds almost like science fiction.
They almost are. It's quite cutting edge. These are materials created using biotechnological processes.
Like what?
Imagine cultivating fungal
It's
mycelium.
fungi.
Yes, or using bacterial cultures or even algae bioreactors. Their unique aesthetic potential comes from something called organic morphogenesis.
Organic morpho what now?
Morphogenesis. Basically, the forms literally grow. They arise from these natural growth processes rather than being shaped by industrial machines.
So hang on. Instead of a factory stamping out bricks, we're kind of asking a mushroom to grow our walls. That's definitely a new kind of supply chain.
Precisely. And the beauty of it is the factory is alive. It's self-assembling and often carbon negative in the process.
Wow.
Take Politecnico di Milano, for example. They're researching algae biofacades. These don't just sit there passively.
Wow.
They actually generate energy through photosynthesis, and at the same time, they help modulate the microclimate around the building.
That's incredible. Is there much backing for this kind of research?
Oh, yes. There's significant investment. The EU's Horizon NE 2025 funding program,
And
New European Bauhaus, it's dedicated to biofabricated materials for sustainable and beautiful construction. They've earmarked 10 million just to support research into these really revolutionary concepts.
10 million euros just for biomaterials. That's a serious commitment. What kind of revolutionary concepts are we talking about?
We're talking about things like self-repairing materials.
Self-repairing. Seriously.
Seriously. Or surfaces that actively absorb carbon dioxide right out of the air. Facade systems that react dynamically to the climate.
Okay, my mind is slightly blown.
And when you compare these biofabricated materials to, say, concrete or steel, the differences are just stark. We're looking at materials achieving negative carbon storage, not positive emissions.
Right.
Dynamic, adaptive building envelopes instead of just static shells. And true biodegradability at end of life, rather than landfill or, downcycling into something less valuable.
And aesthetically.
Aesthetically, it's a whole different world. Organic variability, biophilia, that connection to nature, sculptural expression, instead of just homogeneous uniformity.
That's a huge shift from how we traditionally think about building materials.
Yeah.
It does make me wonder, though, what happens to all materials, old and new, at the end of a building's life? Can they really have a second act?
Absolutely. And that's becoming a major focus. The circular flow of building materials is being pushed hard at European universities. Through innovative approaches like digital material passports, basically, tracking everything a building is made of, and robotic sorting technologies.
Robots sorting demolition waste.
Exactly. For example, TU Wien, they're developing sophisticated algorithms as part of their carbon footprint reduction project. These algorithms can precisely identify the reuse potential in materials from demolished buildings.
That's clever.
And then there's the artistic side. There's this growing appreciation for what's called the patina of the used.
The patina, like the wear and tear.
Oh, yes, exactly. Recycled bricks, old timber beams, maybe metal profiles that show their history. These are being deliberately used in new buildings as an aesthetic narrative.
So the history becomes part of the design.
Precisely. The urban mining project at Leibniz Universität Hanover demonstrates this beautifully. They show how recycled material can tell an architectural story through things like visible seams, overlays, intentional contrasts between old and new.
What's fascinating here is how these new materials are changing everything about design and function, isn't it? They seem to be moving beyond just being technical components.
They absolutely are.
You mentioned materials transcending their purely technical roles. For someone used to thinking about buildings as just, concrete and steel, how does that actually feel different? Are architects having to completely rethink their approach?
They are, definitely. Renewable materials are breaking free from just being functional. They're becoming tools for incredible design expression.
Can you give an example?
Sure. Take lignin-based biopolymers used in facade panels. Lignin is basically wood glue.
All right.
Integrating these isn't just about storing carbon. It allows architects to create these translucent surfaces that play with light in amazing ways, constantly changing effects. That's actually a key research focus at the Universität für Angewandte Kunst Wien.
Interesting.
And this ties directly into that new European Bauhaus initiative we mentioned, which explicitly promotes fusing beauty and sustainability.
Right. Beauty isn't an afterthought.
Exactly. You see it in things like hemp-based acoustic panels, too. The natural fiber structure isn't just nice to touch. It provides optimal room acoustics. This multisensory materiality is shifting how we perceive ecological architecture. It's not about sacrifice anymore. It's about enrichment.
Making green buildings more desirable, not just functional.
Precisely. And we're also seeing bioclimatic design becoming really integral.
Bioclimatic.
Meaning passive climate control achieved through the inherent properties of the materials themselves.
Oh, okay.
So research at Politecnico di Milano's master program, Building Engineering for Sustainability, involves students developing things like hygroscopic wood facades.
Hygroscopic. What does that mean for how the wood behaves? I think I missed that earlier.
Right. It just means they can regulate indoor humidity naturally. They absorb moisture from the air when it's humid and release it when it's dry. Almost like the building is breathing with its surroundings.
Wow, okay.
And students there are also working with phase change materials, PCMs, often derived from plant waxes, that can store thermal energy passively.
Soaking up heat and releasing it later.
Exactly. And aesthetically, these materials can create these transforming surfaces. You might see subtle color changes when they absorb moisture, or even slight structural expansion during heat storage.
So the building changes.
In subtle ways, yes. This ephemeral material performance isn't just a technical feature anymore. It's becoming part of the architectural design itself. It makes the building feel more like a dynamic, living entity.
This all sounds incredibly ambitious, really exciting, but it raises an important question. Who are the key players? Which initiatives are really driving this transformation across Europe?
Europe is definitely the hotspot, and it's coming from several directions.
Okay.
First, you've got the academic drivers. Universities are huge innovation hubs here.
Makes sense.
Institutions like Politecnico di Milano, Linnaeus University, they're pioneering these interdisciplinary programs and specialized labs. They're training the next generation of architects, engineers.
So the skills pipeline.
Exactly. Through programs focused on everything from advanced building envelopes, life cycle analyses for timber, digital innovation, creating these zero-energy and low-carbon design labs. They're not just teaching theory, they're actively developing the materials and methods we're talking about.
Right.
And that EU Horizon EB 2025 program we mentioned, that's a perfect example of funding aimed squarely at scaling up production of biofabricated materials. But they're focusing on environmental compatibility, socioeconomic integration, and aesthetic quality. All three.
That triple focus seems important.
It is. And then there are focal points like the Renewable Materials Conference in Siegburg. In 2025, they'll again give out the Renewable Material of the Year award, showcasing top contenders in biopolymers, CO2-based materials, new recycling tech. It brings everyone together.
So academics are crucial. What else?
Second, real-world application. It's not just happening in labs. You have things like Germany's Renewable de Energiewende Living Labs. These are actual places where sustainable building materials get tested under real conditions, often plugged into whole energy systems.
Learning by doing, basically.
Exactly. Supported by programs like the BMWK Energy Research Initiative, picture this. Timber hybrid buildings being built, coupled with new hydrogen technologies in former coal regions. The architecture itself becomes a symbol of that shift away from fossil fuels. It's quite powerful stuff.
Yeah, it really paints a picture. Okay, academics, real-world labs. What's the third piece?
Finally, the political and economic frameworks, regulations, and money, essentially.
The less glamorous but essential part.
Pretty much. You've got the new EU construction products regulations setting binding standards for eco-balanced materials, and the packaging and packaging waste regulation, which mandates biodegradable materials in some areas.
So pushing the market.
Yes, but there are challenges. There's still a bit of a certification gap. Experts like Frederick Malmfors from Lignin Industries have highlighted this bio-based materials need better legal recognition as truly circular, easier ways into recycling streams. Initiatives like SCS Global Services Carbon Assured program are trying to address this.
Okay, certification hurdles. What about cost? These sound expensive.
They often are, initially. Biofabricated materials can currently be 30–50% more expensive than conventional options.
Ouch.
Yeah, but that Horizon NB program aims for cost parity by 2030.
Well,
through things like robotic manufacturing, scaling up production with techniques like 3D printing using biogenic pastes, AI for optimizing material use, modular fabrication, basically industrializing the processes.
bringing the cost down through scale and tech.
Exactly. And interestingly, that Renewable Materials Conference also showcases business models where the aesthetics actually create value. Visible wood surfaces, unique biological facades, these can command a 10–15% price premium.
So people will pay more for beauty and sustainability.
It seems so. That premium can help offset the higher initial costs. So beauty isn't just a bonus, it's becoming an economic driver in itself.
It sounds like there's incredible momentum building then. But, what are some of the hurdles? What still needs to be overcome to really scale these innovations and make them mainstream?
You're right, it's not all smooth sailing. There are significant barriers, both technological and, frankly, cultural.
Like what?
Well, the construction sector is just notoriously slow to adopt new things. Typically, it takes 20, maybe 30 years for an innovation to become widespread.
20 to 30 years.
Yeah.
That's way too slow if we're serious about 2045 climate goals.
Exactly. It's far too slow. And the causes are complex. You've got very conservative standardization regimes, a lot of understandable risk aversion among planners and builders.
People stick with what they know works.
Right. And fragmented value chains don't help either. It's hard to get everyone aligned. Linnaeus University actually has a research project called Diffusion of Innovations, looking specifically at this.
What are they finding?
They're analyzing how change agents, the early adopters, the champions, are managing to overcome these barriers. Often it's through building prototypical demonstration buildings.
Ah, the living labs idea again.
Sort of, yeah. These aren't just concepts on paper, they're actual finished structures that prove both the material's performance and its aesthetic quality simultaneously. It helps build confidence, show people it can be done.
So it really is about showing, not just telling. Okay, looking ahead then, what does the future of construction research hold? What's on the absolute cutting edge now? What gets you excited?
Oh, European research is pushing into some truly exciting territory now.
Such as?
We're talking seriously about biohybrid materials, combining biological growth processes like the mycelium with technical support structures. Think of living organisms literally growing around or within a designed framework.
Wow, okay. Merging biology and engineering even more closely.
Exactly. Then there's programmable materiality. Things like 4D printing, that's 3D printing, plus the dimension of time or change using biopolymers that respond to temperature or moisture.
So materials that actively change shape or properties based on the environment.
Precisely. Imagine facades that open or close pores automatically based on humidity. And we're also seeing advances in artistic digitized manufacturing, things like robotic braiding techniques, using natural fibers, creating incredibly intricate and strong structures.
Pushing the boundaries of form.
Definitely. And the really bold vision, the kind being explored at places like the NTUA Summer School on green fuels, is for buildings to become bioenergy nodes.
Bioenergy nodes.
Yeah, buildings that don't just consume energy or even just produce their own, but actively produce and process biomass. They become seamlessly integrated into larger, systemic, circular flows. Imagine a building that's not just energy neutral, but truly regenerative, actively contributing to the broader ecological system around it.
That's quite a vision. We started this deep dive talking about how buildings are transforming from these static objects into living systems. And listening to all this, it's really clear that what we've discussed today is, well, it's truly just the beginning of this material renaissance in construction.
It really is. And as you, our listener, think about the buildings that surround you every single day, maybe start considering the materials they're made of. Hopefully this deep dive encourages you to think a bit more critically about how these materials are produced, what their life cycle really looks like, and what incredible possibilities exist for their future.
Yeah, absolutely. Imagine a future where the buildings around you literally breathe, maybe change colors subtly with the weather, or even grow some of their own energy, adapting and evolving almost right before your eyes. What stands out to you about that possibility? What feels most exciting, or maybe even most challenging? Something to think about.